Hello and welcome back. In this part we are going to create this second deflector. Then using the circular pattern tool we will create these two additional instances. We will next move to the outlet side of our spiral casing and we will create these four parts. Because we are going to be mostly working on this area, we do not really need to have all these sheet metal components visible, but still we will have to display them from time to time for visual reference. Instead of each time have to select all the components, then hide them, and later select all the components and show them, what we are going to do is to use configurations. Displayed configurations records what components are shown and what components are hidden. By default, you have this default solid edge configuration. To add a new configuration, click on this new button and then enter the name of the configuration. I will enter parts and then OK. Now we can activate the parts configuration, then OK. And next we will select all the components we want to be hidden in this configuration, then right click and select hide. Now only parts are visible and we make sure that we save this configuration. Now if we toggle back to the default configuration, you can see how all the components are displayed, and if we toggle to the parts configuration, you see only parts are displayed. We are going to create another displayed configuration for sheet metal components. So again we select new and we'll enter sheet metal, then OK. Next we will select the sheet metal configuration, then OK. Hide the part and then show the sheet metal components and hit save. Now we have three configurations. One which is the default configuration, all components are visible. One for sheet metal components, and then one for the parts. We are going to keep this configuration as the active configuration, and now we will create the second deflector. So radial menu, create part in place. We make sure that we have the right template selected, and we make sure that we enter the part environment after the component is created, then right click and we'll enter D2 as deflector 2, then hit save, and now we are inside the part environment. Ctrl Q to show assembly components, then we will show the sketches, the master sketch and this sketch 16. Okay, now we are going to use the extrude tool from a coincident plane and as usual XZ plane. Then the include tool, we make sure that we select wireframe chain, and we are going to select the deflector and right click to accept, then close sketch, hide the master sketch and make sure that we have this symmetric extend, and we are going to select the endpoint of this line in the sketch 16 and then finish and cancel. Now we will hide the sketches and return to the assembly. Okay, as you can see, when we add this new component, we switch back to the default solid edge configuration. Because we want all the components in our assembly visible in this configuration, we are going to hit save so that this component will be recorded as part of this displayed configuration. Then we will switch to the path configuration, then click OK. As you can see, the new component is hidden in this configuration. We are going to make the component visible, then select save. Now we will use the circular pattern tool to create 2 additional instances of this deflector. As we did when we create the circular pattern of holes in this part, we need to first create the sketch that will define the circular pattern. We will make sure sketches are visible. Then we will start a new sketch on a coincident plane, which will be CX. Then orient normal to the screen, and we will select the circular pattern tool, and the center point will be the origin, and we make sure that we select the center point of this arc of the second deflector. Now we have to define the number of instances we want. We will enter 4, then enter. Now we have to define the site from where the count will be initiated. So we select this site and click to generate the preview of the pattern. As you can see, we will have 4 instances, but as we don't want this additional one, we are going to select the pattern cycle again and move to this suppress occurrence button, and now we are prompt to click on the occurrence to suppress, then right click to return to the pattern edit. So we will click on this one, then right click to return to the pattern edit, then click to finish the pattern edit. And now we can close the sketch and we will rename it D underscore pattern and finish, then cancel. We'll hide the sketches, not hide all the sketches, but we will hide the master sketch, and we'll move to the pattern tool. The first step is to select the path to include in the pattern, so this part, then right click to accept. Now you have to click on the part or the sketch which contains the pattern, so you select the sketch, and now last step, click on the pattern, this one, and finish. As you can see, we have these 2 additional instances created, and we have this group pattern 1 on the assembly tree, and inside the group you can see the 2 additional instances. I'm going to make sure that we save the configuration, and we will hide the pattern sketch. Now we can proceed to the next component, and it will be this one. We have few dimensions on this view, and the others are on this section view. So we are going to add a new component. Make sure we have the right template, and we will enter the path environment when the component will be created. Then we rename the component R3, then hit save. So far we used the extrude tool, the cut tool, the revolve cut tool, and the hole tool, and this time we are going to use the revolve tool. We make sure we have the coincident plane option selected, and we select this plane as the coincident plane, normal to the screen, and we are going to sketch the profile of the part. It's not really complicated, something like this, horizontal, and like this, vertical, horizontal, and close. Now we will create diameter dimension, So we use this tool again, the origin element, the origin, and this line. Now we can use this option to display the full dimension or just the half dimension. So full dimension, you see you have the two extension lines displayed, and with the half you just have one extension line displayed. So this time full dimension, so this will be 720. Then right click to reset the tool, select the origin again. This dimension should be 675, enter, and right click to reset again, and this one should be 685. Okay, now we'll enter linear dimensions. This one 30, and this one 127. Okay, now we are going to make sure that we connect this endpoint or this line to this face of the second ring. The way to do that is to use the connect tool. So we select the connect tool, and as you can see, we cannot select anything on this part. To make the selection possible, what you have to do is to move to this tools tab and select peers. Now we can select edge on this part. So let's go back to normal to the view, and we make sure that we select the projection of the external edge, and as you can see, the sketch is now fully defined. And as we did with the revolve cut, we have to create the axis of revolution. So there it is, and close the sketch and make sure that we revolve 360 degrees and finish, then cancel. Now we are going to create this counterboard threaded hole. To do that, we are going to use the hole tool, and we are going to make sure that we start from a parallel plane, and we select the XY plane, and maybe Ctrl Q to hide assembly components, and we make sure that the distance is 358, then enter, and make sure that it is in this side, and we will orient the sketch normal to the plane. And now we will move to this option button and make sure that we select counterbore as the type. Then the diameter of the counterbore will be 40 millimeter, so we enter 40, and we make sure that the counterbore depth is measured from the plane we use to create the counterbore hole. So we select this option, and we will enter, let's say 40 again, and next we will activate the thread option, and we select M20. So this will be 20 by 1.5, and make sure that the thread is to the whole extent, and we make sure that we have this true next option selected for the whole depth, and then OK, and we will place the hole somewhere like this, and we can make sure that the hidden edges are visible. Now we will use the horizontal and vertical tool to align the hole with the y-axis, and to finish we will enter this 66 dimension from this edge of the part to the center of the hole, so 66, and then enter. And now we can close the sketch, and we displayed shaded, and now we have to define the side where the hole will be added, so we make sure it will be toward the inside, and finish, then cancel. Okay, now back to the assembly, and we will create the next component. So again, next component R4. This time the component is not really complicated. You'll again use the Revolve tool on a coincident plane. Ctrl Q to show the assembly components, and this component will be the same outer diameter as the previous one. So normal, make sure that we have the peer locate activate, and now we will just start our sketch from this endpoint. We enter the distance, I think it is 40, then click to place the line, then vertical, horizontal, and vertical, and we click on this edge again and close the sketch. Now linear dimension, this will be 9, and next we add symmetric diameter dimensions from this to this endpoint. The value should be 650, then enter. We'll right click to reset, select the origin again, and select this endpoint, then place the dimension, and the value should be 625. Okay, our geometry is fully defined. We don't forget to add an axis of revolution, and close sketch, make sure 360, and finish, and it will be all for this component. Close and return to the assembly. Since we added two components, we should update our displayed configuration. The way to do that is to move to this configuration manager button, then launch the configuration manager. As you can see, all the configuration are listed. So we have the default, parts, and sheet metal. On this column you have all the components inside your assembly, and this column displays the newly added components, and the lines or the cell in gray indicate which configuration has not been yet updated for this new component. So we are going to move up to the bottom, and now you can see we have all these lines in gray. The new components are these two instances of our second deflector and these two newly added components. So we are going to make sure that all these components are inside this configuration and also in this configuration, and we are going to keep this unchecked, and then we will hit save. We will activate again the configuration manager, and we should have make sure that all the components are selected inside the default configuration. So select them all, and save. Now this time if we activate the default configuration, you can see all the components are visible. We will hide this sketch and we will save the configuration again, then switch to the parts configuration, and they are all there. Now we are going to create these two sheet metal components, and to do that we are going to first create a parallel plane at 750 from our coordinate system, and from this parallel plane we are going to create another parallel plane at 130 and a coincident plane right at this face of this component. Okay, so you'll move to the features tab. On the planes panel, we'll select parallel. We will use the XZ plane as the reference plane, then enter 750, and we will select this newly created plane as the reference, and we will enter this time -130, and we have our two first parallel plane created, so escape. Now a coincident plane from this face, okay, and escape. We will rename this plane, so right click and rename, and we will enter 21. The second parallel plane will be 20, and the coincident plane will be 19. Okay, now we will show one of the cross-section sketches. Select the number 3 so that we can use the tear off sketch to copy this sketch, and then right click to accept, and we will rename this one to 21, then finish and cancel. We'll edit this sketch to properly position the sketch and dimension it. So we'll remove these two constraints and make sure we are a bit away, and using the connect tool as we did plenty of time now, we'll connect it to the origin, then the two. Okay, I'll hide reference plane so we can easily select the origin. Now the classic symmetry constraint, and we'll enter angle value, and we'll use 0.5 degree, and we'll create a diameter dimension. So this one will be 700. Enter, and we make sure that these two lines are construction lines. Okay, and close sketch. Okay, so sketch 21 is done. We will show the reference planes, and we will tear off this sketch. So we select the second plane and we select the sketch, right click, and we will rename this one 20, then finish and escape. For the third plane, we are going to create a new sketch. So we select the plane as the coincident plane, and using the include tool, we are going to select this edge, and now we are going to orient normal to the screen. We are going to project these two lines inside our sketch again using the include tool, and we'll use this trim tool to remove this portion of the two lines and this tiny portion of the arc, and we make sure that the two lines are constructions. We include this inner edge of this component because we have the two diameter equals at 625. Okay, now we will exit the sketch and we will rename it 19, then cancel. We will hide this one, collapse the sketches group, and we will create our two sheet metal components. So create in place, we make sure that we will not entering the sheet metal environment when the part will be created. So we'll select the right template, right click to finish, and the first one will be 1920, save. The second one will be 2021, save. And now we are going to copy sketch, so we'll copy this sketch in 2021, then again copy sketch, this sketch in both 1920 and 2021, and this last one only in 1920. Okay, and now we can proceed to create the sheet metal components. Control Q, and right away lofted flange from this one to this one. I click to finish, then escape, double click on the next component, lofted flange, first profile, second profile, then okay, maybe we are, as you can see, the starting point were not correctly lined up, so we'll go back to the cross section step, then edit. We select this profile to be edited, then we will select this option, redefine starting point, and we select this point, then right click to accept, and as you can see, the lofted flange is properly created now. Then finish and cancel. Okay, now back to the assembly. You will hide the sketches and the reference plane also, and we make sure that we update the configurations. So everything, these two should be checked on this configuration, and on this one everything is still selected as it should, and we'll hit save and make sure that this is okay. Okay, the parts configuration okay also, except for the sketches. I don't quite understand why. Okay, but anyway, I'm just going to hide them and save the configuration, this one as well. Okay, all the sketches are hidden already, so save. On this configuration, sheet metal, which is not okay, I don't know why. Configuration manager, and you can see that there is a problem. Okay, I'm not sure how well this tool is working, so remove all these, and maybe there is a bug. And take these two, and then save, and now you'll see. Okay, I forgot to select this one. I think what we will do in the future is to select and hide component from there. You no longer use the configuration manager. It is not quite working as I expected. So sheet metal, save, then try parts, okay, and default, okay. Okay, that will conclude this part. In the next part, we are going to keep adding more components and moving steadily towards the end of this tutorial. Hope to see you there, and thanks for watching.